Welcome to the deep dive. You send over some really fascinating material on the James Webb Space Telescope and exoplanet K2-18b.
That's right. Some really intriguing findings.
Yeah, potential signs of life. Let's just jump right into what this actually means.
Absolutely. The sources you shared, they paint a picture of something potentially groundbreaking. So our mission today is really to pull out the key info and, figure out the significance.
Okay, K2-18b. Based on the readings, what's the deal with this planet? Why is it such a hot topic?
Well, K2-18b is what scientists are calling a Haitian planet.
Haitian.
Yeah. Think basically a world covered in oceans, but with a thick, hydrogen-rich atmosphere.
Okay, ocean world. Got it.
And it's big, significantly larger than Earth, over 8 times the mass, actually.
8 times. Wow.
Crucially, as the articles point out, it orbits its star right in the habitable zone.
The Goldilocks zone, right? Not too hot, not too cold.
Exactly. Which means temperatures could be right for liquid water.
And liquid water is key, based on all the astrobiology basics.
It's considered essential for life as we understand it. Plus, it's, relatively speaking, quite close, just 124 light years away. Makes it easier to observe.
Right, so big, potentially wet, good location. Now, the discovery itself, the JWST findings, what did it actually see? What's causing all this excitement in the reports you looked at?
This is where it gets really interesting. The telescope detected dimethyl sulfide, DMS.
DMS, okay.
And also dimethyl disulfide, or DMDS, in its atmosphere. Now, the thing is, here on Earth, these specific compounds, DMS especially, are overwhelmingly produced by life, primarily marine microorganisms like phytoplankton.
Phytoplankton, those tiny ocean plants, base of the food chain sort of thing.
Exactly those. So finding these molecules way out there, it's a pretty suggestive find. One of the papers you sent called it the most promising biosignature we've detected so far.
A biosignature, like a chemical fingerprint for life.
Precisely. It's considered the strongest potential biosignature found on an exoplanet yet.
What makes it stronger than, say, finding oxygen or methane?
Well, in certain contexts, oxygen or methane can be produced by geological processes, non-biological stuff. But DMS and DMDS, especially in a watery environment like K2-18b might be on Earth, they're really strongly linked to biology.
Interesting.
Now, we have to be careful, of course. The sources are clear. We can't completely rule out non-biological explanations just yet.
Right. We need to be scientifically rigorous.
Definitely. But the conditions assumed for K2-18b make a biological source seem, well, quite plausible. Very exciting, anyway.
So, okay, stepping back, what's the bigger picture here? What's the real significance of finding these molecules based on these reports?
For the search for life, it kind of opens up new strategies. It tells us maybe we should be specifically looking for these sulfur compounds, especially on these Haitian worlds.
Gives us a new target to look for.
Exactly. And the reading suggests these Haitian planets might actually be pretty common out there.
And how's the scientific community taking it? You mentioned Dr. Niku Mathusahan from Cambridge in the material. What's his perspective?
Yeah, his team's paper, which you included, really emphasizes that this is the most compelling evidence we have to date for potential life signs on an exoplanet.
Compelling, okay.
Yeah.
But there's always a but in science, isn't there?
Usually. He and others are rightly stressing, we need more work, more observations.
To be absolutely sure.
But try and rule out any other possible explanations, any non-biological chemistry that could mimic the signature, and ideally, to confirm it, is biological.
So it's a really exciting maybe for now. What kind of future research are they planning, according to the sources?
The next steps involve pointing JWST back at K2-18b. A lot.
More observation time.
Right. To get more data, measure the amounts more precisely, maybe look for other related chemicals that life might produce alongside DMS.
Refining the atmospheric models, too, I imagine.
Absolutely critical. Understanding the specific atmospheric chemistry of a Haitian planet is key to interpreting these signals correctly.
It really is incredible. Just 124 light years away. A world that might host life. Makes you wonder how common these conditions really are.
That's the big implication, isn't it? This discovery, as your sources suggest, hints that maybe the necessary ingredients, liquid water, stable atmospheres, aren't that rare.
And our technology keeps getting better at finding these hints.
Exactly. We're getting better and better at detecting these potential biosignatures. It feels like we're edging closer to answering that huge question, are we alone?
Truly mind-bending stuff. Okay, as we wrap up this deep dive into the material, what's one final thought that sticks with you?
Just imagine, if follow-up observations do confirm it, if we knew definitively that life exists on K2-18b, Think about how that shifts everything. Our whole understanding of our place in the cosmos, the sheer potential for life out there. It's
Well, it's why we look, isn't it?